work done by a constant force. Okay, here when a constant force means what? The force remains same, there is no change of the value of force. Okay, when a constant force F acts on the body, it creates the small work done, that is the dW. Okay, by the force in producing a small displacement, it is called dr. Okay, so considering the thing here, there are two axes here, x and y. Okay, so in the x-axis we are taking that value of r, is meaning of position of the object. In the y-axis, consider that f cos theta acting along the y-axis. Okay, so constant force means what? F is constant, there is no change of f remains same at the initial and also final position of the object. So right, Ri is the initial position of the object, or F is the final position of the object. Okay, see this line means force is constant, force does not vary like this. Okay, so now we are defining then what is the work done. So we are defining this region. Clear? This meaning of work done, the formula W is equal to F into dr. Okay, but we write that small work done is called dW. Okay, is meaning of what? Small work done. It is producing a small displacement, producing the small displacement. That is dr. Okay, so now we can define that the formula for work done of a constant force, dW is a small work done, that is equal to the force is F cos theta into dr is the distance traveled. Okay, now we are defining that total work done. Okay, total work done, that is W is equal to, so we have to integrate that the small work done, this dW, that became a total work done. Okay, with that position. Okay, so we have the ranges here. So initial position, then final position. So write initial position, then final position of the object. Clear? So W is equal to integral of dW with the limits of Ri, then Rf. Okay, next you see that right side, that is equal to, in the right side we have F cos theta into dr. Here F cos theta is constant, so taken out of the integral F cos theta, only that dr is variable, so write integral of dr with the limits of same Ri and what? Rf. Okay, so here see integral, then d is called what? Differentiation. Both are in opposite character, so we cancel to each other. The same thing. Okay, so now we have only W with the limits. So write W, total work done, is equal to, see the right side is what? F cos theta is there, then we have R only. Okay, then upper the limits, upper limit Rf, lower limit Ri. Okay, therefore work done is equal to F cos theta, upper limit minus lower limit. Okay, so we'll write Rf minus Ri, that is the what? Work done by the constant force is acting on the object. Okay, next is the work done by a variable force. Okay, here the force is variable means what? Is not constant, it is changes at every time. Okay, so x is in a same position, r in the x-axis, then f cos theta in a y-axis. Okay, here f is not same, so we can write like this: f is changes means first increases, then gradually decreases, like this. This is the meaning of what? Variable force. Okay, how? This is what? Initial position of the object, that is Ri. This is the final position of the object, Rf. Okay, now we want to find out that what done by this variable force acting on this object with the moving the object of Ri to Rf. Okay, in these cases we have to find that total work done by the separating the parts like this. So we have to separate the parts like this to find the integral form easily. Okay, so the formula for the small work done for this first plane means you write dw is equal to f into dr, so f cos theta into dr. Here f is variable, also the position theta also variable, so we will write in these cases both f and theta are variables. Here f is constant. Okay, so both are variable means you will write total work done w is equal to integral of dw with the limits Ri to Rf, that is equal to, in the right side, see f theta also variable means we put integral for all the things, integral of f cos theta into dr with the limits of initial position to the final position. So this is the formula for finding the total work done for that variable force. This is for what? Constant force. This is for a variable force. Okay. Next we see that about energy. Okay. So energy, I have told, is the meaning of what? Capacity to do work. Capacity to do the work. That is the meaning of energy. Okay. Next, in other words, you can say work done is the manifestation of energy. We can converting work from energy and vice versa. Okay. Then the important aspect of energy is that for exercise system, the sum of all forms of energy, okay, that is the total energy remains constant. Total energy remains constant. Clear? Which means the sum of kinetic energy and potential energy, that is the types of the energy, okay, that remains constant. This means that the energy is disappearing in one form or ready to change. Okay, energy is disappearing in one form, that is reappears in the other form. Clear? That is the meaning of what? Energy. So we cannot create nor destroy, but we can change the energy from one state to another state. Clear? So this is known as the law of conservation of energy. Okay. Now we see what is the unit of energy. So unit of energy is what? Joule. So its unit is joule. Its symbol is J. Okay. Now we can say that energy equal to work. Okay, so the formula for energy you can write W formula is F. W is equal to what? F into D. So you're writing as a energy E also. Okay, so this unit of force is what? Newton. The unit of distance is meter. So Newton meter also same of the unit of energy, or what? Joule also unit of energy. Clear? Next we see that what is the dimensional formula for this thing. Okay, so F into D means what? F is, that is we have M L T inverse 2. Then distance means what? L. So L into L square. So write M L square T inverse 2. That is the dimensional formula for energy. Okay. So what is the concept? Energy we can counting as a work done and vice versa. See what is symbol is what is the division process. We can changing energy into work and work into energy. Clear? Next, what is the types of energy? We know that what? Kinetic energy and potential energy. So first is kinetic energy. There is a Ke. Its formula is what? Of mv square. Of mv square. Okay. Its definition means kinetic is what? Moving. Okay. So energy possessed by a body. Energy possessed by a body to its motion or moving is the meaning of what? Kinetic energy. So the moving object producing energy, that is the meaning of kinetic energy. Okay. Next, second type is what? Potential energy. You write PE. This formula is, you know, that what? mgh, mass, gravity, height. Okay. Here same concept. Potential means what? Stable. Okay. So energy possessed by the body. Energy possessed by a body by virtue is imagine virtue of its position. That is the meaning of potential energy. Okay, this means stable. For every stable object, it has energy itself. That is the meaning of potential energy. Clear? That is the concept of energy and its types. Okay. Next, you will see that what is the SI equivalent of other units of energy. So SI means what? Systematic integration of units. Okay. So we are using the different field for the same energy. Okay, but in a different words. Okay. So we are converting as a energy. Okay. So first in CS unit. What is called CS means what? Centimeter gram system unit. We can call that energy, that is ERG. Okay, that is equal to 10 power minus 7 joule, because it's very small in size, so that is energy also very small. Okay. Next, 1 electron volt, that is a EV symbol. You will study in 12th standard. Okay, that is the meaning of electron volt. We have to know that energy of the small atoms, which contains what? A proton, electron, neutron. Okay, so now we have to think about what is the energy of electron, or what is the energy of proton in the form of very small in size, this quantity also. That is the meaning of 1 electron volt. Okay, its value is equal to 1.6 into 10 power minus 19 joule. See, very, very small, because its size is very small, so that it can possess energy also very small in category. Okay. The third thing is what? 1 calorie is the meaning of heat energy. So in the meaning of heat. Okay, so how can get that energy with the action or work? Clear? That is the value of 4.186 joule. That is the value of 1 calorie equal to 4.186 joule. Okay. Next, 1 kilowatt hour, kWh. This energy is consumption by the using in a electricity. Okay, so we are using that electricity means what? We are getting the power, electric power, that is consumed for our using. Okay, so that energy is called kilowatt hour. Okay, that is equal to 3.6 into 10 power 6 joule. See, all of the same unit of energy in joules, but using in a different fields. Clear?